The second unicast address is link local address, which is unicast address that is confined or used in a single link. The figure shows the format of a link local address. As you can see, the 128 bits are divided into two parts, prefix and interface ID. The prefix part is divided into 10 bits that take the value from FE80:10 to FEBF:10, and the second part is 54 bits of zeros. The interface ID is generated using slack or statically or randomly, whether the link local address is created automatically or manually. Before a device uses its link local address, it will perform DAD, duplicate address detection, to make sure that it is unique on the link. Manual configuration of routers link local unicast addresses makes them easily recognized or remembered when troubleshooting or verifying network operations. Link local unicast addresses are used by routers inside a link. For example, routers use link local addresses as the default gateway address in their router advertisement. Loopback addresses. An IPv6 loopback address is an all zeros address except for the last, which is 1. That means an IPv6 loopback address is equal to : 1/128. The loopback address is used by an interface to send an IPv6 packet to itself. The loopback address in IPv6 functions the same as the loopback address in IPv4, which is 127.0.0.1. Unspecified addresses. An unspecified unicast address is an all zeros address, which is : /128. The unspecified address indicates the absence of an IPv6 address. A newly initiated node on an IPv6 network uses the unspecified address as the source address in its packets until it receives its IPv6 address. The IPv6 unspecified address cannot be assigned to an interface. The unspecified IPv6 addresses must not be used as destination addresses in IPv6 packets or the IPv6 routing header. Unique local unicast addresses. These addresses are routable within a local site and should not be round about in the Internet. As shown in the figure, a unique local IPv6 address is constructed by appending a randomly generated 40-bit hexadecimal string, which is called global ID, to the FC00::8 prefix. The subnet ID and the interface ID parts are created in the same way as with the global unicast IPv6 addresses. The first hexbit has a range from FC00::8 to FDFF::8. IPv4 embedded addresses are IPv6 addresses used to aid the transition from IPv4 to IPv6. An IPv4 embedded IPv6 address is an IPv4 address in which 32 bits have an IPv4 address encoded in them. Two types of IPv4 embedded addresses are defined. Number 1, IPv4 mapped IPv6 addresses, and IPv4 compatible IPv6 addresses, which are deprecated. Regarding the IPv4 mapped IPv6 addresses type, and as shown in the figure, the first 80 bits are set to all zeros, and the 16-bit segment preceding the 32-bit IPv4 address is all ones. The last 32 bits in the IPv4 address are represented in dotted decimal notation, so the first 96 bits are represented in hexadecimal, and the last 32 bits contain the IPv4 address is dotted decimal notation. The deprecated IPv4 compatible IPv6 address is almost identical to an IPv4 mapped IPv6 address, except the 96-bit, which is 80 bits plus 16-bit segments, are all zeros. Another difference is that the IPv4 address used in the IPv4 compatible IPv6 address must be a globally unique IPv4 address.